Erosion is an important phenomenon in a lot of environments as it saps away a lot of nutrients that could otherwise be used by the environment. And so the question is, well, if we want to prevent erosion, what is the best kind of land cover for a healthy watershed? And so the first question I had was, well, what is a watershed, right? And a watershed is just a place where water can drain to, right? And so if we want a healthy watershed, that is, a watershed that doesn't have all the nutrients that an environment wants, well, we can start to vary some of the kinds of land cover that are in an environment, right? And so the next question I had was, what are the variables involved here? Well, as you can see from this simulation, right, we can vary the amount of precipitation for a storm event, right? We can vary the land cover. There's 12 here, and then we can also vary the soil group. And so the precipitation here for the storm event, right, that'll change the amount of runoff that will carry away a lot of this water. And so we ideally want to minimize the amount of runoff that is taking away all of the nutrients from the soil, right? And so, having a big storm event is, of course, going to be very hard to change that. The soil group tells you about the infiltration, right? The amount of water that passes into the soil. And so, if we change around the infiltration, we see that, well, there's going to be more runoff if there's less infiltration, right? So, ideally, perhaps we would want a high infiltration soil group, right? And so then we can take a look at, well, there's a lot of different kinds of land cover, right? Of course, if it's just pure water, right, all of it is going to be runoff, and so, of course, that wouldn't make a very good watershed. If we take a look at developed open land, right, I can take a look at the characteristics of this land, and I can see that, well, there's a lot of infiltration, but there's still, quite a bit of runoff, right? And so that's interesting. If we have developed lowland, I see that the amount of runoff has increased. We looked at developed medium intensity versus developed high intensity. We see that the amount of runoff is increasing quite rapidly. And if we compare the differences between the developed land covers, well, a highly developed land cover is going to be, well, maybe we should take a look at the other land covers, right? If we take a look at barren land, there's still runoff. Now, this is interesting, right? Now we have a forest and there's no runoff, right? And if we vary the amount of water, we see that, except for extreme cases, a forest doesn't really have runoff. So, what's the difference between a developed land cover and a forest? Well, it seems to be just the amount of vegetation, right? If we take a look at barren land and a forest, right, barren land doesn't have much vegetation, and so we see that there's, quite a bit of runoff. Just to confirm, right, let's take a look at other types of land cover with vegetation. Well, shrubs and the like, right? They seem to have pretty good cover. Grasslands, right? Pretty good with the runoff. Pasture and hay, right? Pretty good. Crops, well, crops are, there doesn't seem to be much in the way of vegetation here, so we're expecting a lot of runoff here. And the wetlands, right? An environment that has definitely evolved towards this kind of land cover, right? So, by comparing all of these different kinds of land cover, we can see that, well, the amount of vegetation really does affect how much land or what kind of land cover would be best for a watershed, right? So, ideally, we would use something with a lot of vegetation, right? And so, what practices do we use? Well, we asked questions, right? we defined what we wanted to cover. What was the best kind of land cover for a watershed? We developed and used models, right? This model that we're using helped us to experiment with the different variables that are involved. We analyzed and interpreted data, right? By looking at the water column data, we saw that, hey, the amount of runoff and infiltration and evapotranspiration could change between these different land covers, right? Um, in right, we um, we're using appropriate tools strategically here, right? These tools, help us to just take a look again at the variables, right? So hopefully that serves as a good guideline for STEM practices.